So this is considered 4-3, but in the book, it's a 4-5. Okay? I did. Breaker, breaker.
Is that a 0 or a 0?
That is a 0.
Okay.
It's okay. We'll get there. Okay, so how do you guys think we're going to do this? I don't know if you did this last year. This is very basic. It really is. Anybody have an idea? Go ahead. You could square it there, but that's a pain in my arse, and I would hate it.
Add 5 to the other side.
I would add 5. By the way, this ugly color is here because she told me to. This area. And I listened to mermaids. Who wouldn't, right?
She's a mermaid.
Well, she's Ariel as a human.
Yeah.
Do we need to put you in a boat and we can say, la 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 la?
I'm good.
You got a guy that you want to kiss? Maybe. I'm a good seagull. Now, how do we get rid? Sorry, I thought. How do I get rid of this? Square it. Now, ladies and gentlemen, this is the time that we introduce sometimes numbers that we cannot be. Is because what if this answer was a negative? Can a square root equal a negative number? No, so right there you should be able to tell. But if you kept going, like I am going to, you would get an answer. Because we just introduced, when we square something, now it becomes a positive number, and there's still going to be solutions. Does that make sense what I'm trying to say by that? We introduce other solutions. So therefore, you need to check your work every time. That's a key important thing, okay? And sometimes you'll get 2 answers, but neither of them might not even work. Sometimes you'll get 1 solution, and it doesn't work. Sometimes you get 2 solutions and only 1 works. Does that make sense? So you might always want to check. Subtract the 1. So x is 6. So how do we check our work? You just plug it back in. 4 times 6, 24. 24 plus 1, 25. Square root of 25 is 5. Oh, technically it was a minus 5 originally, right? So square root of 25 is 5. 5 minus 5 was the 0. Any questions on this so far? Like I said, I think it's a fairly simple idea. Okay. So can somebody tell me, once again, I'm going to write back at this question here. What's another way I could write this instead of having a square root? What could I write? 4x raised to the 1/2. Notice, why do I square something to get rid of a square root? Because it's reciprocal. And what do you do on a power to a power? You multiply, right? Does that make sense what I'm saying by that? So that's why they undo each other, because they are opposites, and when you go power to a power, you multiply, and when you multiply reciprocals, that'll always come to 1, won't it? Does that make sense to everybody? We feel comfortable with that? Okay, so when we come to this problem, I don't know if you guys can read it. 2x plus 3 raised to the 2/3 equals 8. Okay? So we cannot take the square root or whatever we need to do to get rid of the 2/3 power yet. Because we always have to have the thing that's being raised to by itself, meaning I need him by himself. So what do I need to do with that 2? I need to get him to the other side, right? So I'm at x plus 3 raised to the 2/3 equals 4. Are we okay with that? Okay. Now what do you guys think I'm going to do? How do I get rid of something raised to the 2/3? We don't multiply it. We raise it. Right? This is raising. How do we get rid of this? We raise it to the 3/2. So I'm going to ask you guys to raise this guy to the 3/2. Okay, so with this being said, okay, how did you get 8? Besides, did you plug it in? Okay, so without plugging in, this is something you should be able to do in your head. How can I do this in my head? Well, go ahead, Lexi.
Don't you, oh, wait,
That's okay. What does this represent? A 2? That's a square root, huh? What's the square root of 4?
16.
Nope. 2? And 2 cubed is 8. So you gave me x plus 3 equals 8. Guess what? You'd be wrong here. Can anybody tell me why I'd be wrong at this point a little bit? I'm halfway right, I would say. No, not yet. It's to this stage. This is semi-correct here. Go ahead. Plus or minus. Did I not just take a square root? Isn't that what this is a square root?
Yeah.
Anytime you have a divisor of an even number, when you raise it, that is taking an even root. And when we take even roots, you need to do plus or minus. So you got to be careful of that as well. That's something, a big thing most people forget. Okay? Yes, ma'am.
So why don't we multiply the 4 by 3 and just divide it by 2?
Because it's not multiplying. It is being raised. So you could raise 4 to the third, which is 64, and take the square root. What's the square root of 64? Same idea. Right? But usually sometimes these numbers are larger, and you don't really want to simplify a large number raising it to a cube, do you? So usually we like to look here and say, oh, that's the square root of 4, which is 2. 2 cubed is here. So this is technically plus or minus. Now think about this, guys. Let's go actually back and think. Okay? Whatever number comes in here, right, when I square it, it comes out positive anyway, doesn't it? And then I take the cube root of it, then times it by 2. So what happens here is because of that squared, there's going to be one answer, the same answer twice, right? Because notice if you think about 8 and negative 8, what are they squared? 64. Both of them, 8 and negative 8, both when they're squared is 64. And what's the cube root of 64? Both of them. 4. There's only one answer. Because we just squared negative 8 and 8, which gets you the same number up here. Does that make sense what I'm trying to get at? So therefore, though, when we go backwards, there could have been 2 answers that we could have got there. Does that make sense?
One of the answers be when we plug it back into the equation.
5? Yes, we're almost there. So let's just go ahead and go x equals negative 3 plus or minus 8. By the way, you are not done here. Do not stop here. I have a lot of people that stop here. Do not stop here. What if it was negative 3 plus or minus 2i? Would I stop here? Yes, but do we know what negative 3 plus 8 is?
Yeah.
As Weston just said, what is that? 5. Do we know what negative 3 minus 8 is? Negative 11. We can actually stop there. We can continue to simplify. Now, once again, do we need to check our work?
Yes.
Sure we do. Come back at the original. It was 5 and negative 11, correct? 5 plus 3? 8. Squared? 64. Cube root of 64? Cube root of 64 is 4. 4 times 2 is 8. Negative 11. Negative 11 plus 3? 8. Negative 8. Negative 8 squared? 64. Cube root of 64? 4. 4 times 2 is 8. Are we okay why both solutions would work? Yes, ma'am.
Would it be possible if one solution doesn't work?
Can be sometimes. But that's why we got to check both. Okay? Was that too hard? Hardest thing you're going to have to do there is what? The plus or minus, right? If this guy was flip-flopped, if this was 3 halves at the very beginning, because then what would I do to get rid of a 3 halves? 2/3. Would I have a plus or minus on this one? Because you're doing a cube root when you take it. Does that make sense what I'm trying to say? Remember, when it's an even root on the bottom, that's when you're going to go ahead and have to do the plus or minus, okay? Yep, any even root, exactly. Okay? Awesome, we're cruising, guys. Mr. Huff did something pretty cool yesterday. Yes, he is Mr. Buff. I wish my pets were there. What did you say?
You're thinking way at first, it's crazy.
Somewhat.
Maybe for his next, but.
Who would ever make that?
I don't know.
Might want to park it.
Yeah. I learn something every day. Okay, here we go. So, now we have a crater similar to crater. Okay, problem 3 has a diameter. I'm guessing it's
Yeah, it's like, uh-oh.
oh, funky butt loving. Yeah. That's where I was writing earlier. Okay, here we go. So it says a crater similar to the one in problem 3 has a diameter of 1 kilometer. What is? Oh, I don't know. What is V equals 2 cube root of V over 0.03.
Is that negative?
Point.
0.
Point. Oh crap! I'm off.
And then a little.
Why would we? I hate square problems. Use this in physics and chemistry. That's where it belongs.
Next to the 3.
Use. Say what? Why? Where is the zoomer at? I put in D for 1. Just solve for B. So we divide, so that's a half, right? That's a 0.3. Is that better? It's hot in here. Luckily I don't listen to Blitzen fucking. I will keep on all my clothes. Nelly, that's what it was. It was a great song back in the day. Are you guys doing a Nelly dance already?
Well, it's called it, yes,
How do we get rid of the cube? Cube root and cube him. That's 1/8 equals V over 0.3. So that's 0.3 over 8 equals V. You guys know this is the same thing as 3/80ths. How does that, anybody know how that's the case? Ashley's like, I don't know where that came from. Because we got 0.3, that's 3 over 10, isn't it? Over 8. Which is the same thing as times by an 8.
Volume is 3/80.
Well, 3/80ths of a kilometer. I don't know. We just did some math. Yes, sir.
I thought you were doing it again.
How did that become an 8? Because it's 1/2 cubed. And 1/2 times 1/2 times 1/2 is 1/8. Awesome. I hate that problem. Let's go on. Okay. We're talking too much, Weston.
Yeah, Weston.
And I gotta go to the bathroom. We need to hustle.
Let's go.
It's a career decision if I go in here. Okay, what do you think we're going to do? Is the square root by itself? What do I need to do? Minus the 3. Now what do we do? Square it. I might let you guys go on from here really quick. No way.
As an exponent.
6x plus 9. Because you're going to FOIL him. Think about what 3 squared is. 3 squared means 3 times 3. I can't distribute a squared through a parenthesis. So this would be x squared minus 6x plus 9. You guys remember that?
Is that a test to see who?
No, I just know a lot of people forget. No matter how many times we teach it, you guys just like, oh, I can bring it in. Well, watch. Can you really bring it in? 1 plus 2 squared. What should that really be? 3 squared, which is 9. What you guys do are like, oh, that's 1 plus 4. Oh, that's 5. Doesn't make sense here, does it?
No.
So why does it make sense with variables? You should be able to do the same things with variables as you can with numbers. Right? So if you ever run in doubt, check it. Try it. See if it makes mathematical sense. Right? Okay, so what do you guys think we're going to do here? Hey, stick with me. One side, I like you, James. Not that I don't like everyone else here. I only hate 2 of you in here. Not naming names. That's back one. And then we factor. So it comes out to be x equals 10 and 1. Okay. Hopefully by now you know how to factor, right? How many of you guys are busting down into these really quickly now? That's the goal. Remember at first you're like freaking out, but now it's a little bit easier because we're consistently doing them, right? Okay, so then once again we got to check our answers. 10 and 1. Go back to the original. 5 times 10. 50. 50 minus 1.
49.
Square root. 7. 7 plus 3.
10.
And does 10 equal 10? Okay, let's check. Was it 1? Okay, 1. 5 times 1. Minus 1. 4. Square root of 4. 2 plus 3. Does 5 equal 1? So therefore, once again, the math came out to make it work, but 1 was not our answer, so x just is 10. Nope, you just say x, because it doesn't work. The only thing that makes it work is 10. Does that make sense to you? Okay. The question all the way up here, it says, when should you check for extraneous solutions? Basically, really, extraneous was that number, that 1 right there. It was a value that you solved to get an answer, but it doesn't work. It says, when should you check for extraneous solutions? Anytime you square a variable, you should check. Just to let you know. Why? Because right now, okay, hey, hello, sorry if I'm too loud, that might be scary. Come on in, little midgets! I mean little people. You look like you're a lemon-head boy. Thank you, cut down that aisle right there. Oh my goodness, there you go. Hold on. You look like you like. Have a good one. Oh, what's Elsa's sister? What's her name? Anna. Hello, Wonder Woman. Hello, ladies. Ladies, can you all look? Hi. You like nerds? Because I got some nerds. Do you like licorice? Because that's what you're getting. Skittles? Hello. There you go, little fireman. Thank you, brother boy. Do you like Laffy Taffy? Chuck that thing in there. You look like a deer too. Look, Care Bears. I used to watch Care Bears. Yes. Don't be mocking the Care Bears. I don't like Packers, but I will give you one because you're cute. You look awesome, Mr. Spider-Man. Are you Easter Bunny? Yeah. There you go. Let's see. You need to have nerds.
Thank you.
Hello. I don't know what you are because I didn't watch those things, but you get some lemon head. I like lemon head. A little chick. Duck. Oh, you get 2. Yep. Take them. Hello, Iron Man. There's some licorice. High five, Iron Man. Where are you at, brother? Oh, yeah. Thanks, guys. Some Starburst. Do you like Starburst? Open that thing in. Thank you. Is that the end of yours?
Yeah.
Thanks, guys.
No way. More people.
More people.
Just one.
Just one.
the rear. One big cute zebra. Oh, yeah.
Okay, since I know
Oh, your
you.
leggings are
Yes, I
awesome.
think so. There you go.
Wow, we got hooked up.
Yeah, we got hooked up.
Oh,
Awesome.
say thank you.
Bye.
Bye-bye.
See you guys.
See you later.
Thank you. Oh, we're recording. Great time. Great time. Where's the $35 marker? Okay. Sorry, that's gonna be on there. Onward, let's do the next one. Ooh, I like this one. This one's a good one. Okay? This one is more your guys' ability range, meaning something that challenges you. Weston? You were probably an x squared plus 9 kid, weren't you? Uh-huh. It's okay. You probably were too. Okay. We can't just square the left side because of the minus sign. Does that make sense? It would not get rid of both squares. What it then becomes would be a binomial squared, and I don't want to multiply that through. Does that make sense as a foiling product? Okay, so what I'm going to do is have this guy equal this guy. Does that make sense? I'm going to have to FOIL no matter what, or distributed process. Okay? How do I get rid of the squared on the left side? Square it, right? Is everybody there with me? Yes, no, maybe so? Okay. So while over here, I'm left with 5x plus 4. Don't get overwhelmed when I do this, okay? It's really just tedious and long, but it's not hard. Okay? This is not x plus 16, people, once again. It's x plus 8 root x plus 16. Okay? Why? Because of the fact of the matter, if I did this, this is also right here, square root of x plus 4, right? Square root of x times square root of x is x. Square root of x times 4 is 4 root x. Square root of 4 times root x is 4 root x. That's where the 8 root x comes in. And then 4 times 4 is 16. Are we okay with that? Okay, now who has the square root? This guy right here does, doesn't he? So we want him by himself now. So I'm going to now subtract the x over and the 16. This one kind of sucks because we're going to play with fractions. I don't like that 8 there, do I? So what do I got to do? Divide it out. So this becomes now 1/2 x squared minus 3/2. What I would personally do is, what do those guys have in, not x squared? Sorry. Sorry, that's the next step. What I would personally do is pull out the 1/3. No, the 1/2. Does everybody see the 1/2?
Yeah.
Because they both have a half. Because I'm not factoring out a 1/2. I'm not subtracting out. I'm dividing out. Or, you know what I mean? So then how do we get rid of the squared over here? Square root. We got to square it. This is what some of your problems look like. Okay, what is a 1/2 squared? 4. 4. Now I got to do x minus 3 squared, which becomes x squared minus 6x plus 9 equals x. No. Because if I factor, I go back right to this step here. But notice, because I'm out here, how can I get rid of that 4? I can just multiply them to this other side. Not divide, we don't like to divide fractions, do we? So I'm now at x squared minus 6x plus 9 equals 4x. Right? Then what? We're getting there. We only got like 3 more steps in that. So we subtract them. It is tedious. The thought process really isn't too hard if you just think about it, right? Then what do? Allie? Now we factor. So what are my x values? 1 and 9. So what do I got to do? Check them. So I go back. Oh. Go one way. Yeah, you're getting to be real mathematicians, people. 3 pages, 1 math problem. What was my answer? Is 1 and 9, right? 5 times 1? 5. 5 plus 4? 9. Square root of 9? 3. Minus square root of, was it 1 I plugged in? 1. So that's 3 minus 1, which is 2, which is 2 equal 4. So 1 does not work. Okay, now we got to try 9. 5 times 9? 45. 45 plus 4? Square root of 49? 7. Minus square root of 9? 3. 7 minus 3, does it equal 4? So x equals 9.
So, okay, so is it possible that there will never be one? Like, you got 2 answers and neither one works?
So if there's the one you just don't count it, is that what he's asking?
Yeah. No, what he's asking, he says, is there a possibility that both answers won't work?
Oh, what do you do next?
Well, because what happens is like I said, let's scroll all the way down here a little bit more. Like I said, sometimes, like you're doing work, and it comes out to be a negative number, and you keep working on it. Right here, you already know it's a no solution. Because can a square root equal a negative number? Does that make sense? Right there, I already know I'm done. But what if you miss that? You continue doing it, you're going to get an answer, correct? And so then your answers won't be right because there already is a no solution. Does that make sense what I'm trying to say by that? Okay. I kind of want to go through one. It might not be pretty, so I'm going to make it up. But I know there's one on your homework. And it's not too shabby, actually. But it looks like this.
Without time. Anything is possible. How does that work? I feel like that's a cheese.
A square root is a square root.
Actually, that's not bad.
You guys know what the square root is?
It can't.
The fourth root. Think about it. Isn't this x minus third raised to the half? Raised to the half? It's just a fourth root. It's a different way to make a fourth root.
So is this over?
Can you do that in your calculator?
You could, but it won't help you solve.
Oh yeah,
Because x equals like some crazy number.
Anyway, here we go. How do we get rid of the square root? Square it, right? So then I'm at square root of x minus 3 because the square root only got rid of the first square root, didn't it? Right? Everybody with me on that? Now once again, I made this up so it might not be pretty. Okay? I squared both sides. Now how do I get rid of the square root again? Square it again. So I'm at x minus 3 equals, let's see if you guys can say this besides some people that already know, the people that said it should be x squared plus 16. Should be x squared plus 8x plus 16. And once again, this one might not come out pretty, but I just made it up. Once again, please, I made it up. So that's why the one that you have on your homework today, because there is one on your homework, might come out nicer.
Yeah,
So 0 equals x squared minus, plus 7x plus 19. So if it can't factor, do I just stop? I do quad. That's the thing. We know other ways, right? So x equals negative b plus or minus square root of 49 minus 4 times 1 times 19 all over 2a. And this is an imaginary number anyway, so I'm done.
So when you have to do the quadratic, it's just that.
Well, no, it's not quadratic because that's 49 minus 76.
Oh, so.
49 minus 76 is negative 37, right? 27, I apologize. And we can't have a square root of a negative number.
So we add those.
We could, well, we could get some, we'll keep going. What the heck? We've learned imaginary numbers. Is there a real solution to this?
No.
There's still not. So how do I simplify that guy? Negative 7 plus or minus 3I root 3 over 2. On your thing, I don't know how they do it on their homework, so I'm just curious, do you guys ever write, do you see it like this? Negative 7 halves plus or minus 3I root 3 over 2?
Not really.
Do they usually, I think they just put the numbers in, don't they? Like make you round or something?
I don't think we had a question that had a.
Anyway, but you guys know that I can just put it under both of them, right?
Yeah.
Yeah.
Solve it, if both of the roots are in back in. Yeah, how would you just plug it in?
Well, when you plug it back in, it's already imaginary. That's why I'm kind of like, there's no real solution. I think that's basically because I think we're only solving for real solution. So that's why I said, oh, we're already done. But I'm like, just in case. Because when you plug it back in, there's already no real solution. So that's the hard part. You know what I mean? And when you plug that back in, have fun with that, okay? Okay. Are we okay now?